This is the 5th lesson of Unit 3 on x-intercepts of a quadratic relation. So just as a review, the x-intercepts, or the x-ints as I like to call them, of a quadratic equation are also called the roots of the parabola. Okay, so again, x-intercepts, roots, and zeros, which we dealt with last unit, are all interchangeable. They all mean the same thing. Okay, so in the last unit, when we were graphing a parabola in vertex form, we needed the following information. So we needed to know the vertex, right, which we knew was HK. We needed to know the equation of the axis of symmetry, which we knew was x equals h. Okay, we knew that, or we needed to know the y-intercept, which was when x equals 0. This is kind of a new thing, the y-intercept reflection point. So that just means the same point mirrored over the axis of symmetry. So you would mirror over axis of symmetry, okay? And that's axis of symmetry is what I mean by that, okay? The direction of opening, so if we had a positive a value, we were opening up. If we had a negative a value, we were opening down. We needed to know, is it vertically stretched? If a was greater than 1 or positive, then it was, right? It was a stretch. If a was between -1 and 1, a fraction or a decimal, it was compressed. Okay, so that was all the information we needed to graph if we were in vertex form. So this note, we are going to focus on how to graph if we have an equation in standard form, okay, which again we've talked about throughout this unit. So if we have it in standard form, what we need to know is the coordinates of the roots. So the coordinates of the roots are given by the factors. So specifically, to figure out those coordinates, if we had factors, x plus r and x plus s, and again, r and s here are just variables, right? They just represent a number. We would set those equal to 0. So x plus r equals 0, x plus x equals, or s equals 0, and we would solve for the variable. Once we solved for the variable, we would have the coordinates of the roots. And we're going to do examples of this. So this page is kind of just to get you thinking. You will likely have a better understanding after you see the examples. So we also need to know the axis of symmetry. So we can actually figure that out given our factors. So we have a special formula that we call x-vert. Okay, so that means it's the x coordinate of the vertex, right? And in order to find that, what we need to do is we need to find the middle point between them. Okay, so in order to find the middle point, what we're doing is we're finding the average. So all we have to do is we have to add those numbers together and divide by 2. Okay, and notice that those r and s, those are your two factors, right? So those are going to come from here. Okay, and again, you'll get a handle on this when we do a couple examples here. Okay, in order to find the optimal value, which we know is the y value of the vertex, we are going to have to sub in our x vertex and solve for y. So this is just going to be substitution. And that x vertex, you'll notice everything kind of is attached here. So that's x vertex is coming from that equation. Okay, once we have it, we're plugging it back into that original formula and solving for y. Okay, the y-intercept in standard form, which we've learned in this unit, is the c value of this equation. The c value in the equation. okay, EQN equation. Okay, that y-intercept reflection point, again, we just learned about above. We're just mirroring the point over the axis of symmetry. And again, I will show you that on the next page. The direction of opening and any vertical stretch or compression, we are going to be looking at the A value. Okay, just like in vertex form, our A value here in our standard form is going to represent the direction and the stretch and compression. Lastly, we're going to need to know the vertex. So for standard form, remember the vertex is a combination of that axis of symmetry and the optimal value. Okay, the axis of symmetry is the x value, the optimal value is the y. Okay, so now that we know what we need to know, let's actually go ahead and find that information and use this standard form to graph. So just give me a second to pull up the page. We're going to do 2 examples here just to ensure that you understand. Okay, so example 1. So it says graph the parabola defined by y equals x squared minus 6x plus 5. Okay, and this is going to lay out your steps beautifully, so this would be a good reference point. So step 1 is to factor the trinomial to find and plot the roots or x-intercepts of the parabola. Okay, so this is where your knowledge from the last lesson comes in. Okay, you need to know how to factor in order to do this. Okay, so because this is a trinomial, again, I'm going to draw myself my chart. I'm multiplying to get my C value, which is 5, and I'm adding to get my B value, which is -6. Okay, so I'm trying to come up with 2 values that multiply to give me 5. So my first thought is, well, 5 and 1, right? But those will add to +6. But what if I make them both negative? -5 times -1 still multiplies to give me 5. And now it will add to give me that -6. So we know that those are my factors. Okay, so once I find those factors out, I'm going to write it in factored form. So I have x minus 5 and x minus 1. Okay, like I said on the last slide, in order to actually find the coordinates, we need to set these factors equal to 0 and solve. So I have x minus 5 equals 0. And x minus 1 equals 0. Okay, at this point, we're just solving for the variable, so it should be really simple, right? We need to get x alone, so we need to move that -5 over our equal sign. When we move it over, it becomes positive. Same thing with the -1. This means that my x-intercepts, or my roots, are at 5, 0, and 1, 0. Okay, so I can go ahead and plot those on my graph. So 5, 0, and 1, 0. And remember, they have to be on the x-axis, right? They're x-intercepts. That's what they mean. That's what it is. Okay, so step 1 done. Next, we need to find the axis of symmetry. So again, that axis of symmetry is the midpoint between the x-intercepts. Okay, so in order to find that, we use our x-vertex formula. So we have x-vert, remember, equals r plus s divided by 2. Those r and s are just simply the values of x you found above. So we can call 5r and 1s. Okay, so we have 5 plus 1 divided by 2. 5 plus 1 is 6. 6 divided by 2 is 3. That means we have our equation, our equation for the axis of symmetry is at 3. So I'm just going to draw a dotted line, to represent that equation of the axis. Okay, so it's at 3. That means that's the middle between 1 and 5. And as you can see, if you look at the actual graph, we can see we're going over 2 from 1 and over 2 from 5. So we know that, yep, we did that math correctly. That is the middle point. Okay, so once we have done that, our third step is to plot the y-intercept. Okay, well, the y-intercept is just c in our equation. So we look up here, and our c value is 5. Okay, so c equals 5. That means our y-intercept is at 0, 5. Again, our x has to be 0 because we have to be on that y-intercept. So that point would be right here. Okay. Next step is to plot the y-intercept reflection point. So all we have to do is we have to plot that same point on the other side of my dotted orange line here. So I can see to get to that dotted orange line, I have to go over 3. 1, 2, 3, right? Then I'm at the middle. So that means I have to go over 3 from the middle the other way. 1, 2, 3, put a point. Okay, so all I did was go over 3 units from your axis of symmetry to plot that point. Okay, step 5 is to determine that optimal value. Okay, like I said on the last page, to determine that value, we need to plug in the axis of symmetry and solve for y. Okay, so the first thing I'm going to do is I'm just going to write out my equation. So y equals x squared minus 6x plus 5. Okay, now we are going to sub in x equals, what did we figure out? 3, right? X equals 3, and that is your axis of symmetry. Okay, so I replace x with 3. Okay, so that was my first step. Sub in the axis of symmetry for x. Step 2, solve for y. Okay, so all we have to do is basically simplify this equation. So 3 squared, we want to use BEDMAS, right? 3 squared is 9. Negative 6 times 3 is negative 18 plus 5. So 9 minus 18 is negative 9 plus 5 is negative 4. Okay, so our optimal value is negative 4. So opt value. Okay. The next step is to plot the vertex. So remember, our vertex is just axis of symmetry and optimal value. So we found that our axis of symmetry was 3, and we just found that our optimal value is negative 4. So I'm going to go back up to my graph here and plot the point 3, negative 4. So 3, negative 4 is right there. Okay? And my last step, my step 7, is to draw a smooth curve between all the points. Use the step pattern if necessary. So for this one, we don't actually have to use the step pattern because we have 5 good points there. So all I'm going to do is I'm going to connect those dots to form a parabola. There we go. Okay, so even though we were just given the equation in standard form, we are still able to graph it. So we're going to do one more example here. It's going to be very similar to this one, just to help you kind of grasp this concept of graphing when we're given something in standard form. Okay, so example 2. So graph the parabola defined by y equals 2x squared minus 8x. So notice that we don't have a trinomial here, right? We have a binomial, so it looks a little bit different. So again, these steps are going to be the same, right? So the first step is to factor so that we can find the roots and plot them. So remember, when we're factoring, and I should have even looked at this for the first example, we always need to look and say, can we common factor this first? Okay, so in this case, remember, when you're common factoring, that means you're looking for something that you can divide all of the terms by. So right away, I can see that there's an x in both of those. So I know I can at least common factor out the x. The coefficients are 2 and negative 8. And I know that negative 8 divides by 2, so I can also take out that 2. So when I'm common factoring here, I have y equals 2x, right? Because that's what I'm going to common factor out. Common factoring is just dividing each of these terms by that 2x. So 2x squared divided by 2x leaves me with x. Negative 8x divided by 2x leaves me with just negative 4. Okay, just like before, once I have those factors, I need to set them equal to 0 and solve. So I have 2x equals 0, which actually I'm going to write over here. 2x equals 0, and x minus 4 equals 0. Okay, so if x minus 4 equals 0, again, we're solving for x. I had just negative 4 to the other side, so I get x equals 4. Here, to get rid of my 2 in front of my x, I need to do the opposite operation, which would be dividing, right? So I'm going to divide by 2. 0 divided by anything is just simply 0. Okay, so I found that my 2 points here are going to be 0, 0, and 4, 0. Okay, so I'm going to plot those points, 0, 0, and 4, 0. Okay, my next step is to find the axis of symmetry, which again is that x-vert formula, where you just add those factors together and divide by 2. Okay, so we have just 4 divided by 2, which is 2. Okay, that means my axis of symmetry is located at x equals 2. Come on. Okay, so that's represented by the dotted line. Next step is to plot the y-intercept, which again is just c in our equation. Well, we notice that we actually don't have a c value, right? The c value should just be a number without any variables. So that point is actually just going to be 0, 0, right? Because c equals 0. And if I look, I can see I actually have already plotted that point, right? This point here, which was one of my roots, is also the y-intercept because it's going through both the x and the y-axis. So I'm going to move on. So the next step is to plot the y-intercept reflection point, which again is just mirrored over the x-axis. But again, notice I actually have already done that, right? Because if I mirror this point here, it's 1, 2 to my axis. So then I would go 1, 2 over. So that is just my other x-intercept. So I'm just going to say that's already plotted. So we can essentially skip that step. Okay, step 5, determine the optimal value. Okay, so remember this is when we have to sub in the axis of symmetry for x. So sub in x equals 2, okay, which is your axis of symmetry. I just really want you to know where that's coming from. I'll even draw a line. So that is coming from here. Okay, and then we're just going to solve. So we have y equals, we use our original equation. So I'm replacing, every time I see x, I'm replacing it with 2. And then I'm just simply solving using BEDMAS. So I have 8 minus 16, which gives me negative 8, okay, which is my optimal value. Next, we need to determine the vertex, which is just simply from the information we're given. So the optimal value is the y value. And again, I'm drawing another arrow because the axis of symmetry is the x value. So our vertex is 2, negative 8. Okay, so I go ahead back up to my graph here, and I'm going to plot that point. So 2, negative 8. So it'll be right there. Okay, last step, draw a smooth curve between all points. Use the step pattern if necessary. So for this one, I only actually have 3 points here, right? So for accuracy, I'm going to want to find a couple more. And in order to do that, I'm going to use my step pattern. So remember how I said the a value in standard form is the same as the a value in vertex form. So that means that my a value here is going to be 2. Okay, remember to find this step pattern, you're just taking that original step pattern and multiplying it by a. So 1 times a, so that's 1 times 2, 3 times 2, 5 times 2. So my step pattern is going to be 2, 6, 10, right? And I can use that to plot a couple more points. So remember that step pattern is starting at the vertex, going over 1, and then going up 2. Going over 1, up 6, over 1, up 10. So let's go ahead and use that to plot a couple more points. So if I go over 1, up 2, put a point. Over 1, up 2, put a point. Over 1, up 5, up 6. 1, 2, 3, 4, 5, 6. I already have that plotted. Here, over 1, up 6. 1, 2, 3, 4, 5, 6. Already have that plotted. Okay, let's just keep going. So we can use our step pattern to create one more point, right? We have to go over 1, up 10, put a point. Over 1, up 10, put a point. Okay, and that's as far as I'm going to go, and it's as far as I need to go, right? I have lots of points here to draw my parabola. Whoops. And that last step is just to connect those points with a lovely U-shaped curve. Okay, so this is the end of the note on how to graph when we are given something in standard form.